So thank you to the organizers very much for the opportunity to speak today. And I've really enjoyed everything that I've heard. I mean, it's really opened my eyes to a lot of things. I'm very happy to have the opportunity to show you some of what we've been doing. And I'll just point out that I'm not the lead author on this paper, but I'm the person who's in Athens, so I shall present it. In the 20 minutes that we have, I don't have time. I should check the time, in fact. I don't have time to tell you much about Keros, so I'm not going to try to. I think some of you will have heard about it before. If you haven't heard about Keros, I encourage you to come up and ask me about it afterwards. But there's all sorts of different aspects to the story of Keros. It's situated in the central Aegean, in the small Cyclades, the small archipelago of islands that is in between Naxos, Amorgos, and Eos. And the area that we have been interested in is at the far western end of this island, which is not inhabited today. Interesting. There weren't so many lines of that earlier this morning. That's what happens when you decide at the last minute to copy an extra slide from one presentation to another. There are three main areas that we've been working on. The two special deposits that you see on the left of the screen, the small islet of Daskalio, and the many yellow lines are there to indicate that the sea level was lower in the early Bronze Age, and you could walk from one area to the other. Now, there's a long history of work on Keros, starting in the 1960s. Serious, intensive and long-term excavations began in 2008. And for the latest campaign, which was 2016 to 2018, we wanted to learn from the lessons of the past, and we wanted to change some of the ways that we have been working. And so those sort of three priorities are on the screen there: standardization, systematization, and then attempting to achieve an integration in the flow of information between all the participants on the project. Some of these thoughts were inspired by concepts of multivocality and reflexivity, the sort of willingness to look at how excavation projects are organized and how to try to break down the hierarchical aspects and emphasize the heterarchical aspects. This is not news to any of you. Most projects are facing these kinds of issues, so we wanted to try to face them through how we actually designed our methodology. And we were inspired by some words from Hodder that you see on the screen there, from his 1997 volume, The Archaeological Process, if I remember the title correctly. So one aspect of this was to adopt open area single context excavation, and I'm really grateful to Yanis for having explained that earlier this morning, so I don't need to even tell you anything about that. But you can see on the screen here the difference. One clear difference is in the size of the trenches that we attempted to open, the green ones being the more recent ones, the red ones being from previous campaigns. The single context approach was part of this concept of standardization of practice and recording, and also with this emphasis that we had on micromorphology and soil chemistry, which I'll come back to. But part of it also was a decision to try to implement an entirely digital process. So I really enjoyed the paper before Hector's. I enjoyed Hector's paper as well, of course, but the paper before that by Marcos, where we saw a lot of how one can create 3D GIS from older data, essentially. But what we wanted to do was to try to start from the actual methodology of the excavation in order to approach that, as in what kinds of data do we need? So those were the questions that we really sort of were asking ourselves. And so one very clear answer to that, which is obvious to all of you, I'm sure, but it's not just the answer, it's how you work through that answer, is that all the data need to be georeferenced. So what's the best way to do that? And clearly the best way to do that is for the data to be born digital. Now, it took me a while to realize that that was what we were trying to do. When I first started with all of this, I was mainly thinking we're wasting time with paper data sets, which we then have to type into databases and so on. And that's true. We were wasting time with that, but it's the geo-referencing part of it that's really important. And that's where the solution that we found, which is in the IDIG app, which this is just a little video made from screenshots of the IDIG app, really came to the fore, because although IDIG it's a recording tool, which is it takes its inspiration from GIS-like interfaces. So for those of you who don't know about this, lecture is not about IDIG, so I'm not really going to explain it to you, but for those of you who don't know about IDIG, which is of course developed by Bruce Hartzler at the Agora, if you don't know about it, I'm more than happy to show you a little bit about how it works afterwards, or to talk about it in the questions. But the key point is it runs on a tablet, so you have the tablet in your hand while you're recording. All the records are made digitally, and you record. Everything is geolocated as you record it, so that the data are born ready to be fed into a GIS system. This video is, of course, slightly speeded up just to make it go a bit faster, but you get the idea of how the recording system works. So I think I'll just move on. So that was one side of the recording, and the other side was the extensive use of photogrammetry. We took the probably insane decision that we would not have any kind of paper recording in the field at all. So that included no drawings. And we decided to rely entirely on photogrammetry for recording. And that means you have to do a lot of it. And there's a huge overhead involved in that. Here, that little video was just the record of a single context. Here I'm not going to tell you all about photogrammetry, you know all about it, but here you see trench level photogrammetry. We also have, obviously, site level photogrammetry. And then the products that come out of photogrammetry are all also, they're born digital, but they're also born geo-referenced, as it were. So there's all of that. And I'm going to come to section drawings in a moment. So having taken the plunge to record everything in this way, what we needed was a tool that allowed us to work with all of this data. And the ambition grew. I mean, the ambition grew as the project went on. It didn't start off like this, but the ambition grew that ultimately what we wanted was a single tool which could encompass everything that we're doing, so that there should be virtually nothing that you want to do in terms of analysis and publication that has to be done outside of this tool. So that was really the task that we set ourselves. It involved a huge amount of design work. Firstly, in terms of getting the data into the format that we needed. So from the excavation data side, that was mainly done by Nathan Meyer, and from the photogrammetry side, that was mainly done by Rosie, who's the lead author on this paper. And yes, the next slide shows us the architecture for all of this. And I'll talk a little bit about some of the pros and cons of the architecture after we finish. the architecture is, of course, a little bit daunting, but we have got it set up so that it runs on a server which members of the team can access without having to use their own processing power in order to access it. That's a major problem, and that's the solution that we found, is to run it off of a server. And I hope in the future we can make that available to the public as well. That's certainly the aim. Now, I think that Rosie is now going to talk us through how the system works a little bit in this video, if I can make it work.
Finds have XYZ values and are visible in the trench. Queries can be run across the whole site. In this case, we have just artifacts from phase B in trench on display, but we can toggle through that and also have it for all of the information that we've got. When we click on artifacts, we have all of the information that's relevant to it and also some photographs. And clicking on that will give it to you in a larger window. Micromorphology is also visible in section. Each cross section of it is georeferenced and put in place, and you can also have information and images. So during this excavation, we used photogrammetry to create 3D models of every single stratigraphic layer from the whole excavation site for all 8 trenches. And because of that, we actually can digitally re-excavate the site. So switching layers off one by one, for example. If we click on a layer, the pop-up shows the contact sheet from IDIG written by the excavator. And we can also see all of the related objects, related images, samples, and contacts as well. The exploratory analysis tool can be used with the slice function. And with this, we can create sections anywhere across the site, as many as we like, and at any angle as well, and with just specific layers on as well. There's a lot of interesting things we can do with this. You can also use it to view artifacts or specialist data basically in situ. Switch up these special finds and layers. We'll look over at some of the specialist data that we have, as for example, the bone analysis. We also have lithic soil chemistry, the ceramics data, and many other facets of information that we work with. So with the bone analysis, I'll just turn on this and we'll look at the portions of faunal material within the trenches. And one of the great things about this system is that we can view every trench at the same time within a single system. And here we can make really clear that from an immediate perspective, that certain trenches and certain areas on the site have far higher faunal remains than others. Now moving to trench H, we're going to take a look at some of the soil chemistry. So I'm going to turn on soil chemistry for H's copper values. You can see that there's a concentration of copper in room number 2. And at the lower levels indicating some metallurgical activity, which is clear because there's also a half there. So moving on to some of the pottery data that we have, one of the things we can visualize is fabric, and here I've turned on pale volcanic. So the center points from each context associated with each pottery bag were recorded, which is how we can view this data. And we can see some of perhaps activity and divisions of space across the site, depending which island or perhaps where things were imported from. a lot of PDF and images relevant to the site, and each trench are easily accessible, either in the attachments table or by clicking on each trench's end of excavation 3D model. You can find the trench plans, phasing data, and lots of other relevant things. So just a few of the things we've been working on in this system, although there's a lot of other things, different types of analyses, and many, many different types of data that we can look at, go through, and analyze as well.
Right, I think that's the end of the video.
Finds have XYZ values and achievable over time.
Okay, so there was a lot in there. I just want to just pick out just a couple of things, then I'll finish. So I think we're nearly out of time. First of all, having all of the photogrammetric models in a single system is just it makes it useful. I mean, that's the thing that really when we started this, the question I was always asked is, what are you going to do with this? What are you going to do with this? And the answer lies in being able to have it all in a system where it's as easy and convenient as this to operate. This previous slide showed that you can just select a date in order to see what the excavation looked like on that date. Here I'm switching layers on and off in order to see what the progress of the excavation was through this room. So in terms of what I'm going to do in sitting down, producing the final interpretation of these trenches, this is going to be sort of bread and butter. It's going to be what I'm going to be doing every day, sort of constantly. Here we're looking, I mean, obviously it's GIS, so you can do queries, you can choose whatever data it is that you want to look at using absolutely standard queries. This aspect, the sectioning aspect, I think it was in the video, but I think it needs to be highlighted a little bit. One of the criticisms that gets placed on open area excavation is there are not enough vertical martyrs, bulks. There's not enough bulks left for people to interpret the stratigraphy. Now, my answer to that is that's not how you interpret the stratigraphy, but with this system, we have this amazing ability to create an accurate section anywhere in the excavation we want, a section that never existed in real life because it was never excavated like this. Now, we haven't even begun to explore how we're going to use this. It's such a powerful tool. And bear in mind that it's based on spatially accurate data. I mean, might be pushing a bit far here, but I would argue it's more accurate than a section drawing produced by a hungover archaeologist at 6 o'clock in the morning. But you can shout back at me at that if you don't believe me. Now, Rosie did a lot of clever statistical analyses when she was working on this, and if I had the presenter view in front of me, which I don't, I could probably tell you a bit more about this particular analysis here, but you'll just have to take my word for it that obviously that's sort of bread and butter stuff as well. The soil chemistry, as you saw here, we're looking at lead in Trench A, so this is very interesting because we think we have a lead workshop in Trench A, but we didn't. It wasn't in situ, it was fallen in from above. So that's a very complicated stratigraphic thing to interpret, and that's how we're using the data. Here you see some more metalworking is a very important aspect of the site. So here you see some comparisons between lead and copper. And the sectioning process is very important for the micromorphology, because by the time you take your micromorphological samples, the soil surrounding them has already been removed. So the sectioning process allows you to recreate that. So lots of very interesting stuff. I'm not going to read through all these benefits and costs. The costs were great, including the fact that iDig only runs on Apple devices. That's a huge cost. It's not a good thing. And the tool that we built runs on ArcGIS Pro. That's also a problem because it's not open source. And I don't think we can solve that until until QGIS catches up with the 3D functionality to the extent that we've been using it. But I'm fairly confident that it will catch up, and so I think we will be able to create a version of it in QGIS. I think one tiny point I'd like to make, which has been sort of hitting home to me today throughout the presentations. I think about 20 years ago, beginning about 20 years ago, there was a change in methodological approach, which was really driven by scientific techniques in archaeology. So the need for sampling, the need for different types of samples, and for those samples to be controlled and how they were. That drove a certain change in how archaeology was done. And I think creating a system like this and showing that it works might also begin to drive a certain change in how archaeology is done, because the whole thing needs to be thought about together. It needs to be, I don't know what that means. It needs to be done from the start of the project, from the methodological design of the project. And so I think that could actually drive forward things. I don't know if I'm supposed to say allow or deny to this. Anyone, any ideas? Or shall I just close it? I think that might actually move us forward toward more compatible data sets and higher quality data sets, which are geographically highly defined, which is the basis of GIS. So yes, these are some of the future, the way that we're going in the future. What Rosie has put on the screen here is some of the older excavation data she's been working on to try to do what Marcos was showing us earlier about how you can bring in older data into these sorts of systems. So thank you very much.